In our flight schedule project prototype, we're using HashMap as a container of flights. We call it flight map because what it does, as the HashMap name suggests, it is mapping the unique strings specific to the flight identifiers to the flight objects. So this is an idea of a map type of container in Java library. It's called associative container. So it associates a key type with the specific data element type. And of course, as the rest of the Java generic collections, the elements that you store inside your containers cannot be primitive data types, but they can be any other type of reference that you want to maintain list of inside the map. All right, so let's discuss the two types of maps that we have in Java. There are two types. HashMap is a list of key and value pairs, like we have in our flight map, but it is unsorted. The TreeMap actually sorts elements inside the container by the key values. So the organization of HashMap and TreeMap is very much the same. And so we need to provide the key and we need to provide the value. So there are key and value objects that we must provide to be able to insert these two objects. So this is the key and this is the value, two objects. In our case here, in our example, key is a string and the value is a flight map. So what we do then inside the hash map, we create an entry. So entry is an object, and it's all done automatically when we insert the new element into HashMap or TreeMap. But this entry, element that's called entry, is made up of two object references. One is the reference to the key, and another one is a reference to the value. And so for each key and value that we insert into HashMap, we construct an entry, right? So the entry object is constructed before, so another two objects will be placed inside the entry, another two objects, and we make a set of these entries every time when we insert a new value into our map. And so then the entire map is basically the set of all of these entries. So this is what the map is doing. Okay, and then later on you are able to provide the key object and ask the map to give you the value. So basically the map, when you supply this object to get the value for a specific key, which could be the same as this one, so the map will quickly point to the location of the object which corresponds to this key. So for instance, it may give us access to this object. So this is extremely fast compared to just sequential scan, because remember the hash maps and tree maps are normally used with collections of a lot of items, like thousands of items, where sequential search for specific value would slow down the program significantly. So these are the components of HashMap and TreeMap. We have keys and values, and values we technically store as elements inside the HashMap container or TreeMap container. And for each value, we must provide a unique key. The key has to be unique. It cannot be duplicated. And then once we populate it with some entries that are made up of pairs of key and value pairs like this. So these are entries. So each individual item right here becomes an entry. Then we can provide the key and call a method like get from the map container and quickly retrieve the value that corresponds to the specific key. So the common methods of the map type objects is to clear, which will remove and throw away all existing elements that are already present in the map. We can verify whether the key is already present in the map. We can also search for a specific value, which will execute a sequential search. So we can find out if the value is actually present. So that's not exactly using the key, but just a linear search from the beginning. We can obtain the entire entry set if we want to sequentially iterate through the container. And we also can say get us the value for specific key, or put, which inserts the key in the value into the map. A remove key will remove a specific entry from the container. So let's, and of course the size tells you how many entries, how many pairs of key and value entries are present in the map. What is the length of our map? So let's examine how we use this flight map. So we declare flight map to be a hash map, which is unsorted map but still provides pretty quick access to flight objects based on the flight identification. So this is our flight map, and so now let's examine how we use it. So in populate debug data method, which is present here, I quickly add some airlines, hard-coded airline codes to the array list of airlines. Then I create the random object, and for every airline I generate 3 flights. So I just generate flight numbers randomly in a specific range, from 1 to 100, and then I insert the flight objects into our map. And so what happens is that when the flights are generated with random departure and arrival info right here, the flight map is populated with the flight number identifier and the reference to the flight object. So this is what's happening in populate debug data, which, by the way, is invoked when I construct my schedule. I would like some test data to be present in my system so I can do some testing of the methods of our assignment. So I call this populate debug data inside our flight schedule to initially create some airlines and some flights, so that I don't have to, every time I start the program, I don't have to enter this information manually. So this is an example of a put. So we start with a map object which is empty. So it does not contain any elements, but as soon as we put something in it, it generates this entry that basically our flight number is a string. Okay, so this is a string flight number. Flight is a reference to an object which is flight with plenty of data attributes, and this entry is inserted into the map. Our first entry is inserted here, and this entry is made up of a pair of a key and the value. So this will be a reference to our flight identifier, combination of airline code and the flight number, and this will be a reference to the actual flight object. And this is how we retain our flight objects in this application. We basically construct this flight map made up of these pairs, and that's how we keep track of our flights. And quite frankly, flight map is the core part of the implementation of our flight schedule. So what else do we do with our hash map, which we call flight map? We also, in this sample, I just close these to make a little bit more space for our observation. So, for instance, in the select sorted departures, we execute a for loop which is based on entries. So let's talk about this. So we have a map, right? And we already populate map with entries. Right here. So the map is made up of entries, and there are plenty of entries here inside our map. We populate it with plenty of different flights. So this is all that we store inside the map. So these are entries. And in order to sequentially access all objects inside the map, what we need to do, we need to start with something called map entry. Okay, and map entry matches the key type and the element type or value type stored inside the map. And so this reference entry gives us access to individual entries when we execute this loop. So we say for each entry in this flight map, and we have to call entry set. So entry set will give us the set of all entries inside of our map. So this is just a bunch of technicalities. So then once we have our entry, it's very easy to get our flight. We simply say, give me the value. And so this, in this case, because we're just iterating through every instance of flights sequentially inside our map, is just sequential progress, iterations through all contained values inside the map. We say get value. So entry has method get value, so that gives us access. So for instance, if here we had a string and the reference to the flight object, right? So this was some flight object that we created right here. Okay, so of course, when we say entry give us the value, this flight will be a reference to our flight object. So we get access to our flight object, and this time we don't care what the key is, right? There's some key identifier of this flight, but we don't care what it is, because what we are looking for, we need to be able to find every flight object. And then we make our comparison, and of course if there is a matching airport code inside the flight, and if there's a matching day of the week departure information inside the flight, we make our selections here, and we are able to get together all the flights that match these selections, and then we sort this array list of flights that we collect here, and we return the result. So what other uses of flight map we have in our project? So right here, show unsorted departures, just basically another example of a method. Again, it's the same thing. We go to the flight map that we have inside our schedule, we obtain the entry set, and then we say for each entry, and again, in our sample, we use the string as a key and flight as the data element, the actual reference to the flight that contain in our map, and we say for each such entry, let's just get the flight, and once you have the flight, we can display everything about this flight. So this is just showing departures from the flight, because to be able to display the information, we get the departure information and the departure airport code. When we display flight information, we also, what we do here, we ask the user for the airline code. And so the user enters an airline code, and we go through the entire flight map and select only airline codes in our flights that match the specific code that the user is trying to display for flights for. And this is what is the selection right here in this loop, that we check airline codes or one airline code entered by the user against the airline codes that are available within the flight. And if they match, if they equal to one another, we display the flight. Okay, so this is show flight info. Again, this is just a pretty standard type of loop that once you have the map in your project, in your program, and you now want to access individual entries in this specific map. In our case, you just construct a loop like this. Just be sure that you need to, of course, use appropriate import statements, which correspond to all sort of types that we use in our application. And when you work with map type containers, all of these methods are available. And in our code, we don't have a remove, but you can imagine that if we need to remove a specific entry from the map, we can just take the key and remove element that matches this key. So the maps facilitate access to elements without the need for sequential search. So that is the advantage of the map. But as we have demonstrated multiple times in this application, if we have to, we can still sequentially iterate through all entries in our map.